Okay, I think we're good. Hello, everybody. My name is Lyle Van Fossen. I am going to be doing the demo for Team Gamma's KDM-5560 project, our final project for the year. Team members include myself, Scott Brunton, Jack Washiki, and Zakai Howe. So this demonstration is going to be for a TensorFlow-based chatbot that's going to focus on data from different wiki pages and information uh, pertaining to those. So I guess without further ado, I can go ahead and get started. The first thing that we're going to have to do is we're going to have to do our initial training of the chatbot. So this chatbot trainer.py application is going to go through the initial training session. And that's only being trained on this basic text corpus of just small talk, so like greetings and thank yous and asking about the bot, things like that. So you can see here, this has gone through a few hundred epochs of training, and if we scroll up a little bit, we can see the initial summary of the training model. The model is a sequential model that has a think. Uh, sorry, has about 5 layers in it, and these 3 layers down here are what do a lot of the heavy lifting. It's the tensors that we provide there are based on the amount of topics that we have. So you can see in these first 2 tensors here, we have 16 initial, plus 4 for each new topic that is added to this training corpus. And then finally, this softmax tensor is, or the softmax layer is based on the total amount of topics. So there's no like initial 16. It's just those 6 starting topics there for training. All right, so we are going to go ahead and now run this application. It's easy enough to start it. Just go to pymain.py, and this is going to start up our Flask app, which is just our REST API that interacts with the application itself. And then there's actual uh, text box, chat box front end associated with it as well, just to kind of showcase the abilities of it. So when we first started up, we were prompted with this no user input detected. Perhaps you should train me. We're going to ignore that for now, and we're just going to go ahead and say hello. And its response is hello. And you can see down here, whenever we make a request like that, it gives us a output of it's a logging essentially telling us what the topic the model was most confident in, the accuracy score of that topic, and the other topics that were in the top, I think 5 of that list, and the accuracy scores for them as well. And so for this, we wanted to make sure that the model was actually very confident in its responses. So we made sure to have a minimum accuracy of 90 when actually giving the user a topic. If it is less than 90, it gives us this unknown value. So if I were to continue on with this conversation, I'd say something like, "How are you?" Respond, "I'm good. Thanks for asking." You can see down here it had a high accuracy score for the about topic because I was asking about it. Say something like, "That's great. What are you?" And it'll respond with this larger text saying that it's an AI chatbot and prompting the user to start training it. And you can see down here again, the new topic is whom, which is just the bot recognizing that you're talking about it, and the accuracy score of that, and the other accuracy scores as well. So let's say we ask it something that it doesn't understand. So what is Elden Ring? And I'm using Elden Ring specifically because this is something that our group really enjoyed, and we just kind of use that as an example throughout this process. So I'm going to ask it, what is Elden Ring? And it says, oh, I don't know anything about that. And you can see here that it returned a topic of thanks, but it was not very sure. It was only about 50% sure. So let's go ahead and train this now. So we're taken to this training page, and there are a couple of ways you can actually train the application. One of them is by manually inputting this new token. You can get the topic, an example input, and example responses for that. Or alternatively, you can use this, which is going to take a link here, just a simple HTTPS link. And this is to specifically Elden Ring's wiki. You can see here that it's just various data about Elden Ring, the game. It's all kind of disorganized, just a bunch of information here. So when I click submit, it's going to start the actual scraping of the page and also training of the model. So let's go ahead and look at the wiki scraper. So how this works is again pretty simple. It's mostly just taking the page and using Beautiful Soup, finding all of the paragraphs in the application or in the on the web page, finding the topic, which is just the page's title, and then creating a list of all of these paragraphs and appending them to this all text variable, and then giving that to the training utilities. The training utilities, we're going to be using this generate tokens from topics. So because we know what the topic is, which would be Elden Ring, the title of the page, we're going to give it the topic, and it's going to search through all the text that has been retrieved, and it is actually going to try to get all the subjects. And the subjects is just for each sentence in each paragraph in this text. So get subjects. What this does is it goes through each sentence in the text that we gave it, and it says, okay, give me a list of all of the different subjects, which are noun subjects, in uh, all of the sentences in the text, and then append those to a list, give them back to me. Go back. So we have this new variable called subject with this list of those subjects, and then we make sure that the topic is in the text. So if it's a string that or a paragraph that doesn't have the word Elden Ring or the words Elden Ring in it at all, then we just kind of remove it. And then we go for subject and subjects. We get the cosine coefficient or cosine similarity between those two, the subject and the topic. So go ahead and compare these terms here. And what this does is that it removes the different stop words that appends them to these lists and takes those lists and basically just goes through the cosine coefficient algorithm, appending those to the list, comparing the two new lists that we generated, and then giving us this variable cosine here, which we return as the percent of similarity between the two words that we gave it, or the two topic and subject that we gave it. So now, after that is done, we have this cosine variable, and we make sure to check that if cosine is greater than 50%. And the reason why we did this specifically was because we came to realize that more often than not, things are either very heavily related or not really related at all. So, we'd have something that had like a 20% relationship. It might just be, uh, you know, not important or not uh, even really tangentially related, just happen to share a word, or they can be really heavily related, and we just wanted to make sure that we set a point where we decided this is a good idea to cut it off. So if this cosine coefficient is to our liking, we grab the text and say if the text is not in this list of responses, we append it. And then once that is done, we create this new token, which takes the topic of the page. It creates some example inputs, and these are just manually generated by us. And then it appends that new list of responses. So you can see in training JSON, we have this new token for Elden Ring as a topic, all of the inputs, the various responses. And then now the application has been trained on that new data. You can see down here it went through the training process again. Our new shape of our model is significantly larger with a higher total number of parameters and different sizes for our various layers. So now if I ask this, what is Elden Ring? It gives me more information on it. So Elden Ring is a third-person action RPG. Now say I want to know something more about it, so I can just say more. And sometimes it needs to give more information. It takes a couple of times for it to give you new information because the responses are randomized. There's no rhyme or reason to the order in which they're handed to you. So I can keep saying more, and it'll give me new information about Elden Ring. So you can see down here as we make these requests, the first one, it actually returned Elden Ring with 100% certainty that that was what it was asking about. And then as I click no more, it was again giving me these no more topics with a high accuracy rating. Um, so you say thanks. It knows how to accept thanks. If I could learn how to type. And so this is something that it doesn't know about again. So I complimented it. It doesn't know what a compliment is. It doesn't know how to accept that. It says teach me. Okay, so we can go ahead and do that. So here I'm going to use this manual token generator here. So I'm going to go ahead and input compliments. And I'm going to give it some compliments to accept, some example responses. It's going to say, why thank you, you're too kind, things to accept compliments like that. Going to click submit. And that's going to train it a lot quicker because, this is going to be a smaller token. It doesn't actually have to go and scrape the wiki page or anything like that. We have our topic compliments and all of the inputs for that. And if I can go in here, I'm going to say, you're so cool again. And it knows how to accept a compliment. There you go. That is a general outline of this application. I want to say thank you very much and have a great rest of your night. Goodbye.